Vande Mataram. Today I am going to explain you some concepts and construction of the golden rectangle and the fun with it. See, here I am going to take his first definition of golden rectangle GR is A by B is equal to 1 plus root 5 by 2. This golden rectangle is very important. First of all, let us construct a golden rectangle. So, see, this is the golden rectangle I have constructed. When I take this 2 one side and other side as 1 plus root 5, this is about 1.62. So, 1 is to 1.62 is the ratio. If you take this as 1, then this is this 1 plus root 5 by 2. Now, the most important part of this is that if you divide this, we cut a square from here, then you see that this again is a golden rectangle. I have removed a square from here. Now, in order to show you that this is a square, I am going to draw one quarter circle here. So, this quarter circle, this is A and B first of all I am showing. Now, this is the quarter circle. Now, what I am going to do is I am again going to cut a square from here. If I do that, you'll see, before that I have colored this. Now this is a square I have cut. So you'll see that this golden rectangle and this is also golden rectangle. So I'll put a quarter circle here also and give some color to it. Same color as given. Now see that this and this square, I mean the rectangle, they are same proportion or similar in the language of geometry. Now again I cut here a square and draw quarter circle, color it. I continue to that this particular thing, right? I'm going to do one more of it and see. Now this beautiful shape, you already start seeing this as a seashell, okay? Seashell. So let me show you that in nature this particular shape is available at many places. Some of those are, you see, you have a cactus here. See, the same spiral which you got here is available here. Okay. In fact, this has some relation with Fibonacci also. Now you see the seashell. See, the same sort of spiral is available in the seashell also. How about flower? There are some flowers which show this beauty. Okay, and sunflower, you will have this particular beautiful pattern in which the seeds get arranged. Okay, so this is the seed pattern in sunflower. Now this golden rectangle has been studied by so many scientists. It started right from Euclid. Euclid drew a regular pentagon and he saw that there are many golden ratios in that. Pythagoras was also interested in this. Leonardo Pisa, who is also known as Fibonacci, he also studied this. In fact, this Fibonacci series, when you go ahead with large numbers, the ratio of Fibonacci tends to golden ratio. You see, Fibonacci sequence is starts with 1, second element is also 1, third element is 1 plus 1, 2, then you have got 1 plus 2, 3, then you have 2 plus 3, 5. Like that, if you continue, go on adding the 2 subsequent elements to get the next element, you'll see that you have what is known as the Fibonacci sequence. Please note that Fibonacci sequence was known to Indians also. So therefore, they also knew this golden ratio, but we don't have records. At least I don't have records of Indian contribution to that. Then Roger Penrose, he has designed many tile patterns in which again he uses this particular golden ratio. John Kepler, who is uh, in the European side, Kepler was one who said that Earth is going round the sun. Before that, Galileo also said that, but the Galileo was punished for saying that. And please note that we in India knew this particular thing much ahead, before maybe thousands of years before John Kepler. Kepler was also interested in the golden ratio. Now, I don't know how many of you have heard the name of Le Corbusier. Le Corbusier has designed Chandigarh, which is the first planned city of India after independence. That is, after independence, the Chandigarh was built. I don't know why we stopped there. We did not replicate that idea in the other cities. So Le Corbusier, he was the one who designed Chandigarh city. See, and uh, Salvador Dali was also interested in that. And surprisingly, the pyramid of Gaza or all the Egyptian pyramids, they also bear this golden ratio. Okay, so we have this particular golden ratio everywhere available and makes a beautiful pattern. So many architects have used this, and this particular shape is adopted for the beautiful doors and windows, or you have the picture frames. All these, if you study, you have the golden ratio. In addition, in beautiful human figures also, golden ratio is available. Okay. Now let us go ahead and see how you have this golden ratio in the pentagon and other things. So let me go ahead. Here I'm going to go to graphics 2. Okay, so there I go ahead and see from here you can see the graphics 2 screen. I open that graphics 2 screen. I have some text there, so I click that. So see, the golden ratio can be defined in terms of itself. See, one definition we have here, 1 plus root 5 by 2. Okay. Now second definition is phi equal to 1 plus 1 divided by 5. See, so this is also a wonderful relationship. Then you have, it also can be obtained as continued fraction. See here, 1 plus 1 divided by 1 plus, and again we have got 1 plus 1 plus, like that continued fraction is there. So that also is phi. The phi is the notation used for golden ratio, as you have pi for the ratio between diameter and the perimeter of a circle. It is also a limiting concept. I told you already that in Fibonacci numbers, as you move ahead, slowly it tends to golden ratio. Then it is about 0.60. If you say this as 1.6 or other way around, it is about 0.618. Okay. Now it has a rotation of 225 degrees, and in one direction, in other direction 137.5. Then from the figure a plus b divided by a by b, the other names of golden ratio is also known as golden section, golden mean, golden number, divine proportion, divine section, and the golden proportion. Now this regular pentagon Let us have a look at it. See, you have regular pentagon here. Now if you join these sides also, then please note that you have number of the golden ratios. You see, you have got this A and B. So A and B is in golden ratio. B and C is also in golden ratio. And C and D is also in golden ratio. So you have got A by B is equal to B by C is equal to C by D. All these are in golden ratio. It will be very interesting for you to just construct this pentagon and measure these things, and you will find that they are all in golden ratio. So I hope you like this. See, you please visit my this thing blog or sort of YouTube channel. I have number of things there. For example, I have put up the uh, quadrilateral family, wherein I have discussed all the quadrilaterals. Then I have triangle family, where all the 6 triangles are discussed, and further some interesting properties of logo, etc. are there. Thank you.